Okay, so let's do a full related rates example. Let's say that an airplane is flying overhead at a constant elevation of 4,000 feet. And a man is looking at the airplane So a man is looking at the airplane a distance of 3,000 feet from a radio tower. If the plane is flying at a rate of 600 feet per second, at what rate is the distance between the man and the plane? At what rate is the distance between the man and the plane increasing when the plane flies over the tower? Okay, so there's usually a lot to unpick with these problems. And there we go. So you can see the whole thing. So usually for these things, the first step is just to draw a picture. So we're gonna draw this little picture. Here's the ground. Okay, so supposedly there's a man. There's a radio tower. Hopefully you can see the weird little tower that I'm drawing. Looks like a pyramid sort of. Okay, so there's the man, there's the tower. And how far is the man from the tower? It's 3,000 feet, so I'm going to draw this little line. Okay, cool, 3,000 feet. And there's this airplane up above. There's our stick figure airplane. I apologize for the horrible thing of the airplane. It looks really bad. Whatever. Let's move it over here. Oh, look, it's flying. Woo! Okay, there's the airplane. Now, what do we know about the airplane? It is at a distance of 4,000 feet to the ground. Okay. And it's always at that distance. It's just always, it's going straight basically. It's not ascending or descending. So if the plane is flying at a rate of 600 feet per second, so that plane is moving this direction, 600 feet per second. What is the distance between the man, at what rate is the distance between the man and the plane increasing at when the plane flies over the tower? So the distance between the plane and the man is from him to the plane like so. Let's call this distance D. Or no, let's call it S. S. So as the plane flies away, does it make sense that distance from the man to the plane is increasing? Okay. Cool. So there's the distance from the man to the plane. There's that distance from the plane to the ground. And when the plane is right on top of the radio tower, the horizontal distance from the man to the plane, irrespective of height, is 3,000 feet. So I'm going to call this distance here X. Now when the plane is over the tower, the distance from the horizontal distance from the man to the plane is 3,000 feet. So what's tricky about this is usually you need to figure out what's changing. So as the plane moves away, this distance is changing and this distance is changing. Anything that's changing needs a variable. You don't need a variable y for the 4,000 because the plane is always 4,000 feet to the ground, so no variable is needed. So hopefully that makes sense to you. Let's move this. Let's move it over here. Okay, now I've set this up so that those lengths actually have a relation to them. If you look at S, X, and the height of the plane from the ground, elevation of the plane to the ground, how are they arranged? So if you look at all those numbers and the one number and two variables, what's an equation that relates them? You're always going to need an equation that relates everything. Yeah, exactly, the Pythagorean theorem. We know that x squared plus s squared is going to be equal to 4,000 squared. Okay, and the plane moves the plane moves at a rate of 600 feet per second, and we track the plane moving horizontally with the variable x, so we know that dx dt is 600 feet per second when x equals 3,000. Oh, yeah, my bad. I fucked up the Pythagorean theorem. Thank you for a person in the chat who noticed that. It's x squared plus 4,000 squared equals s squared. My bad. Yeah, the equals the hypotenuse squared. Whoops. So, but like I was saying though, thank you for catching that. That was important. We know that dx dt, the rate of change of the plane at 600 feet per second, that's dx dt. What we want to find is ds dt. So we know two rates here. dx dt is 600 feet per second. And we want to figure out ds dt, because ds dt tells me how the distance between the man and the plane is changing, which is what they're asking me to find. So the hardest part is usually taking the information that they give you, putting it into the diagram, figuring out which parts are just constant and which parts need a variable. It was obvious that the distance from the man to the plane, the straight line distance, was variable. It might not have been obvious that the 3,000 feet from the man to the radio tower, that's actually changing because we're using the radio tower as the place where we start measuring where the plane is moving from. Because as the plane goes further away, the distance from the man to the plane horizontally is going to change. So now that you have an equation which relates all this, you can now take the derivative with respect to t. And this is where implicit differentiation comes into play. You have to take the derivative with respect to t of x squared. You have to add to it the derivative with respect to t of 4,000 squared. And then you have to take the derivative with respect to t of s squared. No, because the 600 feet per second is dx dt, not x. Does that make sense? That you can't just take x squared plus 4,000 squared equals s squared because and substitute in the 3,000, because that will just tell you how far the man is from the plane right now. We want to know how that distance is changing, not actually how far he is. Which is, yeah. Once you realize that, you're like, oh, that just gives me how far, that just tells me the distance between them. It doesn't actually tell me how that distance is changing, which is what the question specifically asks for. They don't want you to, Yep, exactly. Cool, so now we take our derivative. What's the derivative of x squared with respect to t? Well, it's going to be 2x times dx dt. The derivative of 4,000 is just 0, because it's a constant. The derivative of s squared is going to be 2s times ds dt. And now you can start plugging things in. We know that x is 3,000. And what was dx dt? 600. Right? dx dt, the plane was moving at a rate of 600 feet per second. Now we need to plug in what s is. So we actually do need to plug in s and solve for it. So x was 3,000, so you get 3,000 squared plus 4,000 squared equals s squared. So, okay, what is that? 3,000. Cool. Okay, cool. Sorry, I'm gonna get the number here too. 3,000 squared plus 4,000 squared is 25 million, and then we need the square root of wow, I'm just like super slow today. Sorry. So you get all that 5,000 in. So s equals 5,000. Okay, and that gets plugged in here. So you get 2 times 5,000 times the thing that we're looking for, dsdt. That's the rate of change of that's how the distance between the man and the plane is changing. Notice you have 2's on both sides. And then so we can put everything together. You get 3,000 times 600, divide everything by 5,000. That's equal to ds dt. The thousands will cancel. So you're going to get 3/5 of 600, which is 60% of 600. Which is going to be... I can't type today. 60% of 600 is 360. So remember, this was in feet per second. So what does this tell you? It's telling you that if the plane is traveling at a horizontal speed of 600 feet per second, how is the distance between the man and the plane in the straight line increasing at a rate of 360 feet per second? So if the plane is moving at a horizontal, if the plane is moving horizontally at 600 feet per second, then the straight line distance between the man and the plane is increasing at a rate of 360 feet per second. I can't spell horizontally. There we go. So that's what this tells you. Okay, and so it's important to remember the plane is moving horizontally. We're measuring the distance along that green line, not on the ground. If we were measuring, so the horizontal distance is if you imagine that the plane, you were to put a person on the ground moving with the plane, you would see the person on the ground who's keeping track with the plane moving away at 600 feet per second. But I don't care to figure that out. I want to figure out how the distance between me and the plane is changing. That's what the 360 feet per second is.